results display for a second. And turn on this guy. So similar punched opening geometry, similar sawtooth on the east and west. Although now what I've done on the interior is add static louvers in the upper portion, the clerestory portion of the glazing, and then a light shelf which sticks out into the exterior that separates the vision glazing at the bottom from the clerestory glazing at the top. And this is just to give me a little bit, I mean, this light shelf could be interior for lighting purposes, but what we're seeing in the preview here in the viewport by default is just the statistical summary of that annual performance. So using disturbing glare as a threshold, we're saying, okay, if you have no disturbing glare over the course of the year, then that view slice is gray. But if you have as much or more than 5%, then it's red with sort of a scale in between. So this gives us a quick visual summary to say, okay, all the red areas in my viewport are places where I have disturbing glare more than 5% of the time. And this is a number that sort of comes from a few studies on subjective satisfaction of spaces. It turns out that once people experience glare more than even a small percent of the time, around 5%, they start to complain. So comparing this option 2 to option 1, what we see is that percentage of problematic views has gone from 22% down to about 13%. So we've almost cut that in half. And now this is where having these view directions becomes very useful, because you can start to tell a story about interior layouts too. So we talked about imagining this as a concept design project where we're doing the facade, maybe the layouts aren't totally fixed. One thing that both of these maps indicate is that the worst glare problems happen, perhaps unsurprisingly, when you're looking directly out of the facade. So the way I've just schematically oriented the workstations to look parallel to the facade turns out to be a good one, right? So at these locations near the workstations that are near the windows, in general, if you look out towards the window, you can see in the map here, I have intolerable glare or disturbing glare really much of the year, almost every day that it's not overcast. But if I turn to the side, those problems are much more minor. So if I go back and just visually inspect that same time point that was causing issues before, what I'll see is a very different story. So that bright circumsolar region is now getting blocked by the light shelf and the louvers, right? And so what I have is, what used to be disturbing or intolerable is now imperceptible. If I rotate and look, right at the window, maybe it's an issue, but the way I've laid out the workstations, that's not a problem. So I'm pretty satisfied with this design. If even sitting next to the window, we don't really have problems here. Of course, you might ask if, in adding all this extra stuff up at the top of the vision glazing, we've hurt our daylight performance. So maybe we need to circle back and answer that question. As we mentioned at the start, there's comfort, but there's also daylight sufficiency. So are we still providing that? So I'll pause this for a moment and call this option 2 glare. And I'll switch back my question to daylight availability. And of course, I need to specify the blinds again. Now here, I'm going to say that I don't really need blinds in that clerestory portion because it's always blocking direct. So I'll just pick within option 2 my vision glass. Okay, and so what you're seeing here is now we just have operable blinds on the lower part of the glazing, and the upper part with the louvers is just always has the fixed shading.
Surprise! C'est si bon.
Richtig gut.
C'est bon, Gérard Gérard.
Géramo mit Skier. Cremig wie immer, frisch wie nie. Schon probiert?
At MIT, and John Sargent and Jeff Niemas are working full-time for Solemma. As you see in the picture, about once a year, we are trying to reach out for more in-person meetings, which are preferred by everybody, of course, during our Solemma Symposium. The picture that you see here is from the Solemma Symposium this February at the HOK premises in Los Angeles. So before getting actually into the tool, it might be useful to just take a step back of why we are interested in reducing carbon emissions in the building stock. And I guess the two numbers that we are all aware of keenly are, on the one hand, that right now global temperature increases at around 0.8 degrees C. And last year, we globally emitted 37 gigatons of carbon per year. And now when we follow the lead of the IPCC, then we know if we want to, in the long run, keep global temperature rise below 1.5 degrees C, then we have in total about 580 gigatons of carbon left worldwide to burn until 2050. And if we assume now that buildings going to keep their 40% portion within that overall carbon budget, then we know we have about 230 gigatons of carbon left worldwide for buildings until 2050, when the building stock will have to be net zero. So we're thinking here in timescales that are not that long. So there's some urgency to the task for us to make buildings as resource efficient as we can, while at the same time, of course, maintaining the and ensuring the occupancy comfort in buildings. So how are we doing that? For us, we are focusing especially on the architects and their consulting, to combining during the design process, design and environmental modeling within one environment. And while 10 years ago, that was maybe more of a dramatic or a radical idea that architects should do performance analysis themselves, we are now at a point where the American Institute of Architects is endorsing that idea. Here in their recent report, there's this really nice quote: building performance simulation is no longer just a good idea for some architectural practices. It's an essential part of building design and delivery. And we all couldn't agree more at Solemma. So how are we actually going about this? So we are assuming that you have your initial design. In this example, you have the corner of an office building. And now you're using a performance analysis using Climate Studio, where you're looking at the daylight availability, the energy performance, and the visual comfort within your design. And in this case, you might find out that glare is a problem here. So then, of course, the big step is that the information is presented in a way that allows you to change your design, add a shading system, and then you redo your analysis and hopefully find some better results. And we are going to give you an example of that in the following, how to do this type of analysis. So one could say this is, of course, not a new idea. We've been doing that with Diva for Rhino for a long time, where
Nur modeled in a way where everything is assigned in. Hello everyone, so in today's video we'll go over how to do daylight analysis using Climate Studio. So to do the daylight analysis, first we need to have a 3D model modeled in a way where everything is assigned in correct layers. So for example, all the walls need to be in the correct wall layer, the roof needs to be in correct roof layer, glazing need to be modeled separately in a glazing layer or glass, floors need to be in floor layer, etc. The columns need to be in column layer. So once you have all of that, the next thing we need to do is create analysis floor. So to do the analysis floor, let's first turn off everything, the columns layer, etc. The columns need to be in column layer. So once you have all of that, the next thing we need to do is create analysis floor. So to do the analysis floor, let's first turn off everything else. Come to the analysis floor. Right now, analysis floor is basically a singular planar surface that is traced on top of your floor. So come to the analysis, create analysis floor. So to do the analysis floor, let's first turn off everything else. Come to the analysis floor. Right now, analysis floor is basically a singular planar surface that is traced on top of your floor. So essentially the idea is to use that surface to do the analysis on. Once you have all of that, you need to launch that is come to the analysis floor. Right now, analysis floor is basically a singular planar surface that is traced on top of your floor. So essentially the idea is to use that surface to do the analysis on. Once you have all of that, you need to launch Climate Studio. If you do not see these icons up top on your Rhino, one thing you can do is right click in this area, go to show toolbar, scroll down and make sure that Climate Studio Rhino is turned on or checked on. If it's not, click here and it will show up in your top menu. All right, once you have everything ready, turn on all the layers and launch daylight analysis. Okay, so here the first let's park it analysis and ready, turn on all the layers and launch daylight analysis. Okay, so here the first let's park it and dock it on the side. First thing we need to do is assign a correct weather file. It defaults to Boston Logan Airport, but you can first thing we need to do is assign a correct weather file. It defaults to Boston Logan Airport. First thing we need to do is assign a correct weather file. It defaults to Boston Logan Airport, but you can click here on the browse file, and for me the project is in Mountain View. So Mountain View Moffett Field looks okay. Once I have correct EBW file assigned, the next thing we need to check is check compass, making sure that it's oriented in right direction. Display size, I can increase or decrease. That's just size of your north arrow. once you have all of that, it gives you a very basic climate analysis along with it. Next thing we need to do is assign materials in Climate Studio. So to do that, we'll go through every single layer. So to do that, we'll go materials in Climate Studio. So to do that, we'll go through in Climate Studio. So to do that, we'll go through every single layer where we have our geometry and assign correct material. Our geometry and assign correct material. To check this, I recommend referring to your specs. What is a kind of color, material, texture you are assigning, and make sure you pick something that's closest to what you are specifying in your spec section. It is relatively easy to do it for floors, walls, roof, etc. If you don't have a clear idea, and if this is very early design stage, then you can pick something generic like beige wall or light gray floor or like concrete ground, etc. If it's very early and you don't have a clear understanding of what that material is going to look like. The next thing is assigning a glazing material. So to assign glazing material, you actually need to click here on others, pick the glaze, and you don't have a ground wall design stage, then you can pick floors, walls,